Okay, and yesterday in 10.1, Part 1, we looked at 1, 2, and 3 for our objectives. That is, evaluating square root functions, and find the domain of the square root function. Today we are going to be doing, we're going to be skipping 4 for now, and we're going to do 5 and 6, which is simplify expressions of the form square root of a squared, and evaluating cube root functions. And then we'll have a part 3 for this too. So let's turn the page on to page 5 in your notes. And you can see here, you got simplifying expressions in the form square root of a squared. When you simplify square root of a squared for any real number a, what you get is the squared and the square root symbol sort of cancel out, and you just, if we're taking the square root of a squared, you get just the a, but because it's even, we're taking the square root of an even power, you get the absolute value of a. So in words, the principal square root of a squared is the absolute value of a. That's what it says. So let's look at how that works with examples. In example 1, or example 5, I'm sorry, we have the square root of negative 6 squared. And I said that the square root and the squared are going to cancel out. So that's going to kind of cancel out with the square root. And we'll just get the absolute value of negative 6. Well, we know absolute value is always positive. So the absolute value of negative 6 is just 6.
Miss Ben, if you're in the building, please come to the office. Miss Ben, please report to the office.
Sorry about the announcement. All right, moving on. B. On this, we've got just the squared. Again, cancel out with the square root. We get the absolute value of x plus 5. Now, if we have an x in there, we don't know the value of x. So we can't take the absolute value of it. We're just going to leave that as our answer, is the absolute value of x plus 5. See, when on A we knew that the negative 6 was the only thing in there. There was no x. We could take the absolute value of negative 6. It's just 6. But we don't know what x is. We don't know if this is positive or negative. So we just leave it as the absolute value. Let's look at C. You've got the square root of 25x to the 6th. Now you have a power in here for 1. You got a 6th power we got to deal with. And we got a number that we can take the square root of. So we're not just canceling out a square root with a squared. So we got to figure out how we take the square root of these things. The square root of 25, everybody knows. First of all, we know it's going to be an absolute value, and the square root of 25 is 5. So we have that. Now, how do we deal with the x to the 6th? Their power is going to reduce, and the way it works, well, I'll tell you the shortcut first, and then I'll tell you how it works. It's going to be x to the 6th. You just cut the power in half when you take the square root of it. You're basically dividing by 2, which is the power on our square root, or the root that we're taking. We're taking the square root, which means the second root. And so you're dividing by that number. You divide the x to the 6th by that, and we get x to the 3rd. Now, here's how the long way of this, what really happens. If we're taking the square root, I'm just going to do the square root of x to the 6th. I can write x to the 6th as x squared 3 times. It's the same thing as the square root of x squared times x squared times x squared. Now, each one of these x squareds I could cancel out with my square root symbol that's in front. And what I'm left with, if I take the square root of x squared, I get an x. If I take the square root of the second x squared, I get another x. If I take the square root of the third x squared, I get another x. So we got x times x times x. What does that equal? X cubed. So that's the long way of what happens. The shortcut is divide it by whatever root you're taking. We're dividing by 2. We're dividing by 2 because we're taking the square root. 6 divided by 2, you get 3. So it's the absolute value of 5x to the 3rd. Now, D. So this is our answer here. D is a little different. We got a trinomial. We got to go back to that first section that we did at the beginning of the year. You're going to have to factor the trinomial. And so, remember, factoring a trinomial, you split things into two binomials. And the x squared gets put an x in each one x in each front of each binomial. And we have to think of two numbers that multiply to 4 that add to -4, or we do the diamond. And I can't really remember. I think, it's add to 4 on the bottom. Two numbers that add to 4 and multiply to 4 on top, -4 on top. And so what two numbers they are, that fills out the diamond that will finish our brackets. Well, two numbers that add to 4 are, I got that backwards. Got that backwards, don't I? Multiply to 4. Let me redo this. They got to multiply to 4 and add to -4. Multiply to 4 and add to -4. So two numbers that add to -4 and multiply to 4. Well, the numbers that multiply to 4 are 2 and 2, or 4 and 1. If we're going to make them add to -4, we could have -2 and -2. So -2 and -2. So this is what we have now. Square root of x minus 2 times x minus 2. But x minus 2 times x minus 2 is x minus 2 squared. I know a lot of you guys remember on the test I made you guys write the squared, or I'm going to mark you down. This is why. You have to know that x minus 2 times x minus 2 is x minus 2 squared. And now we have the square root of something squared. We can cancel out our squared with our square root, and we get the absolute value of x minus 2. So you had to do a little factoring first to make it a squared, and then once you've made it a square, you can take the square root of it and get our absolute value. Stop here, pause it, try the checkpoints. When you come back, give you the answers. Okay, checkpoint 5. The answers to checkpoint 5. A is 7. B is the absolute value of x plus 8. C is the absolute value of 7x to the 5th. And D is x absolute value of x minus 3. That's checkpoint 5. Let's turn the page and work on cube roots. All right, cube root and cube root functions. So the definition of a cube root of a number is cube root of a real number, a, is written as cube root of a, and the cube root of a equals b means that b cubed equals a. So it's similar to what the definition of square root. If I can take a number, in this case b, and when I multiply it 3 times itself, whatever number I get will be a. That means I can go backwards. That means the cube root of a is b, that number that I started with. So I can take the cube root of a and get b. Remember, cubed is something multiplied by itself 3 times. It's a little different than square root. Most of us know our square roots, our numbers that are perfect squares. Most of us don't know the numbers that are perfect cubes. And so below here, and we're going to do it in a second, after I go through this example, we're going to do common cube root numbers. And so let's look at the example. Cube root of 64. It's going to equal 4, and the reason why is because 4 cubed is 64. So if I can take 4 and cube it, get 64, then the square root of 64 is just going to be 4. Same thing with negative 27. By the way, we can now take the square root, or we can take the cube root of a negative. So I should probably write that in. You can take the cube root of a negative number. Okay, you can't of a square root yet, as of yet, but you can have a cube root. And all it does is just make the answer negative. So the cube root of negative 27 is negative 3. That's all really taking the cube root of a negative number means. And that's because negative 3 cubed is negative 3 times negative 3 times negative 3. That'll give us the negative 27, which is what we started with. So we can't take the cube or square root of a negative, but we can take the cube root of a negative. And one thing a lot of people mess up when saying this is not the third square root or the cube square root of a number. It's just called cube root. Okay, we got square root, which means the root is 2. We got cube root, which means the root is 3. And then you also got fourth root and fifth root and sixth root and so on. Let's look at common cube roots. Let's talk about these now. I'm going to write them down, if I have the room, through 10. So the cube root of 8, the first one, is 2. Actually, I should probably give you the first one too. I'll do that up here. The cube root of 1 is 1. 1 times 1 times 1 is 1. So 2 times 2 times 2 is 8, so that means the cube root of 8 is 2. The cube root of 27, sorry, I'm missing one. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125, that's 5. The cube root of 216 is 6. The cube root of 343 is 7. The cube root of 512 is 8. Oh, let me make a better 8 there. The cube root of 729 is 9, and the cube root of 1,000 is 10. Obviously there's more cube roots, but I'm only going to give you up to a 10. And how would you figure them out if it wasn't one of these common ones? You would take, to figure out 11, you'd take 11 and raise it to the third power, or take 11 times 11 times 11, find out what that number is, and the cube root of that number is 11. If you really wanted to know, I could do it for you real quick. 11 times 11 times 11 is 1331. The cube root of 1331 is 11. All right. Let's evaluate some functions with cube roots. Example 6a says, for each function, find the indicated function value. So that means we're going to find f of 127. So we're going to plug in 127 in for x and subtract 2. So we got the cube root of 127 minus 2. Then we're going to do the cube root of 125, because 127 minus 2 is 125, and we know from our common cube roots above that the cube root of 125 is 5. Not too hard on that. Let's look at b. We're going to do g of negative 7. So we're going to put in the cube root of 8 times negative 7 minus 8. And negative 7 times 8, we're going to have the cube root of negative 56 minus 8. Negative 56 minus 8 is negative 64, so the cube root of negative 64. And again, we can take the cube root of a negative. It's not a not real number, which would be called imaginary. Cube root of negative 64 is just going to be negative 4. Pause here, try the checkpoint. When you come back, I'll give you the answers. All right, checkpoint 6. For A, the answer is 3, and for B, it is negative 2. Make sure you're showing your work during your checkpoints. I'm going to mark you off on your notes if you don't. That's all for Part 2, 10-1 Part 2. I will see you in class tomorrow.